back to Matt Explains Science. Today we will be looking at the international system of units and the accompanying prefixes. So, we have length, which uses the meter as its base unit, mass, which uses kilograms, time, we use seconds, electrical current is based on the ampere, temperature uses Kelvin, amount of substance uses the mole, and luminous intensity uses the base unit candela. Each of these base units is defined by a constant. Since the 20th of May 2019, all SI units are now defined in terms of constants that describe the real world. Let's have a look at them. The meter is defined by the speed of light in a vacuum, whereby 1 meter is the length of the path travelled by light in a vacuum during 1,299,792,458th of a second. The kilogram is no longer defined by the International Prototype Kilogram, a cylinder made of platinum and iridium, as it was discovered that the cylinder had mysteriously lost 50 micrograms since its creation. The kilogram is now redefined in terms of the Planck constant, which has a value of 6.626,07015 times 10 to the power of minus 34 joule seconds. The second has also been redefined from its previous definition as a fraction of a year. This is because it is now known that the Earth's orbit is slowing down, and therefore it was decided to change the definition based on the hyperfine transition frequency of the cesium atom, which has a value of 9,192,631,770 Hz. Electric current is dependent on the elementary charge value of 1.6021,76634 times 10 to the power of minus 19 coulombs. Temperature is defined by the Boltzmann constant K equal to 1.380649 times 10 to the power of minus 23 joules per Kelvin. Avogadro's constant defines the mole, which is the amount of substance of a system that contains 6.02214076 times 10 to the power of 23 specified elementary entities. And finally, the candela is defined as the luminous intensity in a given direction of a source that emits monochromatic radiation at 540 times 10 to the power of 12 Hz and a radiant intensity of 1/683rd watt per steradian. Detailed descriptions and definitions on base units and the defining constants, please check out the website of the International Bureau of Weights and Measures at www.bipm.org. From the 7 base units, a number of important units can be derived. By simply forming powers, products and quotients of the base units, for example the base quantity length can be multiplied by length to get area with the units meters squared. And if we multiply again by length, we are given volume with cubic meters as its units. If we take mass, for example, with kilograms as its units, and divide by volume, we get density with the units kilograms per cubic meter. A third basic quantity, the amount of substance, can also be divided by volume to give us concentration in moles per cubic meter. We can make some more complex derivatives, starting with length, for example. If we divide it by time, we get velocity with units in meters per second. And then if we divide it by time again, we can get acceleration with unit meters per second squared. Now taking that acceleration, if we multiply by mass, we get force with the units newtons, which can also be written as kilogram meters per second squared. And finally, if we multiply our answer by length again, we get work done in kilogram meters squared per second squared. So as you can imagine, there are a lot of combinations of the 7 base quantities that we could make to create new units. However, of course, not all of them have any significance. Let's look at the meaning of prefixes. Prefixes are used in front of unit names and also indicate the multiples of the original unit. This table shows all of the names of the existing prefixes used. Examples of this would be the kilogram, the gigawatt, the decibel, and finally the nanometer. These are just 4 examples of the many units that can be derived from the original list of 7. And that's it for today. Thanks again for watching. Stay tuned for more content and please like and subscribe.